So we have a polynomial here. And what I'm curious about is what is the remainder if I were to divide this polynomial by, let's just say, x minus, if I were to divide it, I want the remainder, when I divide this polynomial by x minus 2. And you could do this, you could figure this out with algebraic long division, but I'll give you a hint. It is much simpler and much less computationally intensive and takes much less space on your paper if you use the polynomial remainder theorem. And if that's unfamiliar to you, there's other videos that actually cover that. So why don't you have a go at it? All right, so now let's work through this together. The polynomial remainder theorem tells us that the remainder, when I take a polynomial, if I take a polynomial p of x, and if I were to divide it by an x minus a, the remainder of that is just going to be equal to p of a. Is just going to be equal to p of a. So in this case, our p of x is this. What is our a? Well, our a is going to be positive 2. Remember, it's x minus a. So let me do this. Our a is equal to positive 2. So to figure out the remainder, we just have to evaluate p of 2. So let's do that. So the remainder in this case is going to be equal to p of 2, which is equal to, so let's see, it's going to be, I'll just do it all in magenta, negative 3 times 8 minus, let's see, minus 4 times 4. It's 4 times 4 plus 20 minus 7. So let's see, this is negative 24 minus 16 plus 20 minus 7. And so that gives us, let's see, negative 24 minus 16. This is negative 40. Right? I'm just going to do it step by step. This is equal to negative, actually I can do this in my head. All right, here we go. So this is negative 40 plus 20 is negative 20 minus 7 is negative 27. Negative 27. And that was pretty neat. Because if we attempted to do this without the polynomial remainder theorem, we would have had to do a bunch of algebraic long division. Now, if we did the algebraic long division, we would have gotten the quotient and all of that, but we don't need the quotient. We don't need to know. So if we did all the algebraic long division, we would have taken our p of x, and then we would have divided the x minus a into it, and we would have gotten a quotient here, q of x, and we would have done all this business down here, all this algebraic long division, probably wouldn't have even fit on the page. But eventually, we would have gotten to a point where we got an expression that has a lower degree than this. And it would have to be a constant, because this is a first degree, so it would have to be essentially a 0 degree. So we would have eventually gotten to our negative 27. But this was much, 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 much easier than having to go through this entire exercise. Hopefully you appreciated that.